Hello everyone, I'm Xiaogang. Okay, this time we will officially start learning the code for our type disk. And this is different from the third-party library integration and web integration we covered earlier. Back then when we used them, we started building the architecture from the bottom layer step by step. But this time, we have to start building the architecture from the middle layer. Why is it architected this way? Because with this Slate and our underlying interface, if you try to write one side, you inevitably have to deal with the other side, making it not very easy to write. So we will first architect the easier to write middle management layer. And this management layer is actually somewhat similar to the relationship between managed task and task we discussed earlier in country flow. You should still remember that relationship. I think we covered it in great detail back then. It should have been just last week or the week before last. We went into great detail. So this time we will adopt that same approach. First of all, in this part. First of all, here we are. This is our core. What is our most code module? Let's first include the same file here. Include this only code module. But we won't write the code inside it yet. We just need to include it here for use. Okay, so first we define our manager module and we name it this. For this name, same as before, let's start with F, because we are not using U classes here, because we don't want to. Don't want the engine to. If we use U classes, you can use the U class. Many of our standalone programs use the U class. This place uses this thing, because it simulates a subsystem, so we didn't use the U class. And this module, it mainly serves as our core management, this module. So first, we must have our constructor, right? Then we must also have the destructor. The destructor must be virtual. Must be virtual because you just make it virtual. But in this instance, actually, whether it's virtual or not doesn't matter. If you don't check the function elsewhere, if you are not careful, it will cause inaccurate resource release. Well, when your subclass and parent class perform pointer casting during destruction, this resource may have issues. Yes, this is C++ terminology. This is something often asked in interviews. You can remember it and look it up. We should have covered this before. Then, with this constructor, we just put the constructor here. We haven't done any other work. Next, we are going to write our singleton. This singleton is a standard singleton, and we do not allow multi-threading. This thing is only allowed to be used on the main thread. Okay, we call it get. We create its implementation. Then, obviously, for this singleton, we definitely need a static pointer. This way, we can make it obtain the globally unique singleton. So this is a static pointer. Then, here we point to the object we want to instantiate. We'll call this one Xiaogang is for instance. Let's format it. Okay, with this singleton, we need to initialize it outside the class, right? We perform an initialization here, above this spot, and it is a pointer of this type. And it belongs to this class. So we initialize it like this. Then we initialize it as a null pointer. Okay. Then, actually here write our gate. First, we need to make sure it is on the mainline layer. Otherwise, there will be issues with this thing. Then we write an if method here. If this pointer of ours is currently a null pointer, we will let the pointer. Should it be written in the destructor or here? Wrong, here. Okay. We just let it slip out. We just need to let it slip once. Okay, then we can be sure that this one has an object. We just return it. Alright, actually, according to the standard practice, we also need to write a destroy here. Right, we also write a destroy. We just write a destroy. We need to create this method. It's an empty function. And then its main purpose is actually, if this pointer here is not equal to null, then we actually need to delete it. we need to delete it. Then we just set this pointer to null. This way, our resource is reclaimed. Actually, in earlier versions, when we wrote standalone programs, there were some strange bugs, and then the engine's resources couldn't be properly released, etc. But these issues only occurred when the standalone program exited. Our approach at the time was to ignore it. Now, this problem probably doesn't exist. Anyway, as for this destructor, we also need to ensure it is executed on the main thread. Then here we will write two more methods. Obviously, these are our init and tick methods. This is because we don't have a parent class, so we have to write it ourselves. After writing it like this, actually, this is pretty much done. Then next we go to our program. We embed this process into it. Obviously, we are here. Then after we finish the initialization, now we create our object. We might need to include a header file here. We write this diagram file here. Here it clearly shows call, then dot here. Then we go back to this place below. This place is a pointer. Then it points to our xcall. Then we obtain it through the list method. This is more appropriate. After obtaining it here, according to the standard writing style, we should do it like this. That is, we must check whether it has been obtained. But actually we don't need to. This place can definitely be obtained. We just call it directly. Then if there is an init here, obviously, after we finish the loop exit here, when exiting the context, we need to destroy it. I didn't write comments here. Everyone can add some comments, add steps and such. Then in the middle of this process, after all these ticks are executed, what do we need to do? Obviously, we need to add our own tick to it. Okay, as for where to add it, let's add it here. This is a time calculation. Let's take a look at it. We'll comment out this comment. Now we still need this frame rate. Just put it here. Then we take this time, we just drag it over and insert a fixed time. Okay, let's compile it now. There shouldn't be any issues here. Okay, then after this part is done, what do we need to do? We need to design here. And because we have tick here, we don't want to instantiate this object every time and add tick inside the main loop. Once this main loop is written, we won't touch it. So we just need to add a tick here at the tick interface. So we need to do some design here. For this design, we first define a tick. Plus, let me paste it here. We define an interface. We put this interface here. This interface is not needed yet because when using content code, we still use it. We define it as xdspp. That is, you must inherit this interface and you must implement this. This is an interface. Then at this point, we need to use our smart pointer. So how do we do it? Here, we will add two such interfaces called add tickable id. This is essentially a registration concept. Then obviously, this object is it. It is a weak pointer. That is to say, this object, if you need to add or remove a tick, we will put it into our side. Also prepare a container. As for this container, actually placing it here is fine because we want it to be a weak pointer because this object may be reclaimed. We should not let this object know is such management, is such life cycle. We hope the life cycle we apply for this interface through whom. That is, whoever applies for this T interface, then whoever manages this TIC, the life cycle of this smart pointer. We only judge it here. That is to say, only when necessary do we execute it. Then inside this container of ours, we will add this. And note that what we add here is the unique one. Then next, In tick, actually, we will do a remove all. If this object no longer exists, that is, it has already been what we usually call, that is, the resource has been applied for by it, and then it has been recycled. Then we remove it from this array. Then finally we iterate through this tick. If anyone needs to tick, we just tick it. So this is a weak pointer. We need to convert it to a smart pointer. Then tick it. Yes, the writing here is actually not very elegant, so we won't change it. When we were talking about smart pointers, we explained the pain and why. They have this difference, how they should be used. Right. We won't change it here. Okay, so then actually our entire manage task is done. And here we add our task, this task. Okay, then let's compile it first. Alright, so that's it for this lesson. Actually, regarding the subsequent usage process, I can introduce it to everyone. That is to say, when our front-end content box has a button, after you press it, it will generate and request this resource. Then this resource is inherited from this interface. The resource inherited from this interface. After inheriting this interface, it will perform calculations. When the calculation is complete, it will output this data, echo it back into this content box. When this content box is destroyed, this resource will be released. Alright, we'll stop here.